systems and topic.
Hello friends, my name is Rajwardhan Shwanzato and I am from Anna Saheb Dange College of Engineering and Technology Ashta, and subject is Advanced Propulsion System. And for our today's presentation, our topic is types of nuclear propulsion system, and my group member is Mayur Patil, and we prepare this presentation under the guidance of Professor Yuvrashan Mugun sir. So first here we see what is the nuclear propulsion system. Nuclear propulsion includes a wide variety of propulsion methods that use some form of nuclear reaction as their primary power source. The idea of using nuclear material for propulsion dates back to the beginning of the 20th century. In 1903, it was hypothesized that radioactive material, radium, might be a suitable fuel for engineers to propel cars, planes, and boats. In this diagram, we see this is the basic diagram of the nuclear propulsion system. Now, here we can see the types of nuclear propulsion system. There are basically two types of nuclear propulsion system as following. First is nuclear electric propulsion system, and second is nuclear thermal propulsion system. Here we see the conceptual diagram of both propulsion systems. Now, here first we see the nuclear electric propulsion system. Nuclear electric propulsion system use propellants much more efficiently than chemical rocket, but provide a low amount of thrust. They use a reactor to generate electricity that positively charged gas propellants like xenon and krypton, pushing the ions out through a thruster which drives the spacecraft forward. Using low thrust efficiency, nuclear electric propulsion systems accelerate spacecraft for extended periods and can propel a Mars mission for a fraction of propellant of high thrust system. In today's technology, nuclear electric propulsion typically has orders of magnitude less thrust than nuclear thermal propulsion. Therefore, deliver the same total impulse mission requirement a much longer thrusting time is needed, resulting in significantly longer orbit transfer times even with the higher specific impulse. Future mission will require the development of multi-megawatt level power sources and thrusters having long and reliable lifetimes. Now here we see the basic electric propulsion system diagram. There are parts. Here we see the reactor, shield, power conversion, heat rejection, or power distribution, like that. So next part explained by Mayur.
Now we will see the nuclear thermal propulsion system. Nuclear thermal propulsion systems aren't new, but they could significantly reduce travel time and carry greater payload than today's top chemical rockets, giving human a great chance of exploring deep space. The nuclear thermal propulsion systems work by pumping a liquid propellant, the most likely hydrogen, through a reactor core. The uranium atoms splits apart inside the core and release heat through fusion. And this physical process heats up the propellant and convert it into gas, which is expanded through a nozzle to produce thrust. Nuclear thermal propulsion rockets are more energy dense than chemical rockets and twice as efficient. Nuclear thermal propulsion systems won't be used on Earth. Instead, they will be launched into space by chemical rockets before they are turned on. Nuclear thermal propulsion systems are not designed to produce the amount of thrust needed to leave the Earth's surface. A nuclear thermal rockets is a types of thermal rocket where the heat from a nuclear reaction often nuclear fusion replace the chemical energy of the propellant in a chemical rocket. Then now we will see the significant diagram of nuclear thermal propulsion system. There are the parts of nuclear thermal propulsion systems. First, we will see the turbo machinery, engine controller, reactor subsystem, thermal chamber assembly, and nozzle extension. Thank you.